Okay, so today we're going to be talking about using units in chemistry and how we go about converting between them. So the first thing we need to say is that in chemistry, it's very rare that we will use um, anything but metric units. So imperial units or customary units like pounds, feet, and gallons are almost never going to be used. So we do sometimes need to convert between those imperial or customary or standard units and metric conversions. So I'm going to teach you a way to do this that I think you'll find helpful and pretty reliable. So the first thing we need to have in terms of information is some relationships between like miles and kilometers, pounds and kilograms, and so forth. So you have that in your notes. And if you had to answer a question like how many centimeters are there in 78 inches, some of you guys could just look at that table and figure out what kind of math you're going to have to do. But I do want to show you another way that is going to be useful in more different applications when things get harder. So even if you could just look at the table and go, oh, I'm going to multiply by this number or I'm going to divide by that number, I don't want you to try to figure that out in your head. I want you to be very systematic and follow this system that I'm going to give you. So the first thing we're going to do is write our starting number with units, in this case it's 78 inches, as a fraction, which means we're going to put it over 1. Then we're going to take that fraction and multiply it by another fraction. And the unit that we want to get rid of is going to go on the bottom of that next fraction that we just started to write. And the reason for that is we want to be able to cancel inches and get to what the question is asking us for, which is centimeters. So centimeters will go on top. And just like in algebra, when you have the same thing on the top and bottom of a fraction, you're going to cancel that. And in this case, we want to cancel inches and get centimeters. So then the last step is to simply look at the table and figure out the number relationship between centimeters and inches. And if you look up above, we see that 1 inch is equal to 2.54 centimeters. That's not something that you have to know. That would be given to you if you're ever asked to convert between centimeters and inches, but this is how it would work, and then inches would cancel. And we just plug it into our calculator. It gives us 198.12 centimeters. We've had this before with sig figs where we needed 2 sig figs and we had the number 198. This is that weird one where you have to put a repeating line above the last zero that you want to be a sig fig. But that is our final answer, 200 centimeters with 2 sig figs. Okay, let's try another example. 425 liters of gasoline converted to gallons. So we just want to follow the same process, right? We want to write our starting number with units over 1. So in this case, 425 liters. Don't forget your units. If you just write the number, then this technique is not going to be very useful. We have to always include units. So we're writing it as a fraction, and we're multiplying it by another fraction. So think to yourself, what unit will go on the bottom of this next fraction? Because I want to get rid of it. Hopefully you thought to yourself, liters, right? Because that's what I'm starting with. Whatever I'm starting with, I'm trying to get rid of. And then what unit would go on top? Because we're trying to get it? Gallons, right? Now, liters to gallons, again, I don't expect you to know that, so we have to look back at our table and we can see that 1 gallon is equal to 3.79 liters. So we fill in those numbers. That'll allow us to cancel liters and get an answer of 112 gallons. Okay, and so this one actually happens to have the correct number of significant figures because 425 has 3. The conversion factors, 1 gallon equals 3.79 liters. Those don't affect significant figures because they're not measurements, they're just constants. So we go ahead and circle our answer. Okay, this one's a little bit more difficult. It says how many meters would be equal to 3,260 inches? And it does say in your notes, we want to use dimensional analysis. So the words that completes that statement. Dimensional analysis is just the term that we use for this unit conversion method that I'm teaching you by multiplying fractions. So when we say dimensional analysis, that is what we are referring to. So even if you feel like you could do it in your head or just do it on the calculator more easily, there's a reason that we're learning this very systematic, although sometimes a little bit slower method. It saves us from making mistakes usually, and it's going to be utilized later on in the year when problems get a little bit more tricky in doing our conversions. Okay, just like any other problem, we're going to start with the given number with units as a fraction, and we're going to multiply that by another fraction. Now, we should know by now, hopefully, what unit's going to go on the bottom of that second fraction. It's the one we're trying to get rid of. So it's inches. Now, I would love to put meters on top, but the problem is my table doesn't tell me how many inches are in a meter. Now, I could go look that up, right? And then I could come back and complete the problem, but I could also use the table and look at the information given. And instead of going from inches directly to meters, I could notice that I know how many centimeters are in an inch. And that's going to allow me to convert from inches to centimeters. And then maybe I can go from centimeters to meters. So this one is going to be a two-step problem. So now I'm at inches canceling. And if I were to stop here, I would have centimeters. The question is asking me for meters. So I do have another fraction. And of course, again, what unit are we trying to get rid of now? What unit are we trying to get? So at this point, we have centimeters, so we want to get rid of centimeters. Whatever we currently have, we want to get rid of until we get to the unit that our question is asking us for, which in this case is meters. So if you don't know how many centimeters are in a meter, I'll give you a way of dealing with that in just a second. But for right now, just know that the prefix centi means 1/100th, which means there are 100 centimeters in 1 meter, allowing us to cancel centimeters. And now in our calculator, we're just going to multiply 3,260 by 2.54, and then divide our answer by 100. And this should give us 82.804 meters. I think we want to probably take this down to just 3 sig figs. Once again, we're just looking at the 3260 for sig figs because everything else in this problem is a constant relationship. So I'm going to round it to 3 sig figs, 82.8 meters. Okay, so that's going between standard units and metric units. Let's talk about just converting within the metric system. You see this funny little chart in your guided notes. I wanted to show you how to use this. This is a handy system for keeping track of some metric prefixes. For example, you may have heard of centimeters before, or millimeters, or kilometers. Those kilo, centi, milli, those are all metric prefixes. Now, there are a bunch more metric prefixes, and so I'm going to introduce you to a couple of them here. The big ones are the ones on the left. So the capital G on the left stands for giga. So like if you've ever heard of gigahertz or gigabytes, that just means a billion bytes or a billion hertz. It's a very large number. The capital M is also very large, but not quite as big. It means mega. So it's like a million of something. So megahertz, megabytes, all of those things. Kilo is the lowercase k. Notice all the little zeros. Those are just placeholders. Those are just like decimal places. So we're going to kind of ignore those. They're important, but we're not going to worry about what their letters are, how we say them. The box, the middle part, is just the ones place. So that's where you would put your units that don't have a prefix. Like, for example, kilometers is 1,000 meters. Well, if we're just dealing with meters, we're talking about the ones place, you would just put an M. There's no prefix. So liters, meters, grams, seconds with no prefixes. Then we get into the small units. So 10 times smaller than the ones place, we come to deci. So decimeters, deciliters, decigrams, those are tenths of a gram. And then centi, those are 1/100th of whatever the unit is we're talking about. So centigrams, centimeters, those would all work. Lowercase m is going to stand for milli, so millimeters, milliseconds, and so forth. Then we're going to skip a couple, or we're going to go past a couple more decimal places and get to that weird little Greek letter. That's a Greek letter mu. It looks kind of like an M, but it's not. Just do your best to kind of write it. Maybe it looks like a lowercase u with a tail in front, but it means micro. So I'm just going to treat it like an M and write the rest of the words for micro there. So that's very, very small. And then we have nano. So like nanoseconds, nanometers. These are very, very small times and distances. And finally, even smaller, the lowercase p. You may not have heard of this one, but it stands for pico. Really, really small. Okay. So now how do we use this to do a conversion? Let's say we're given a problem. How many kilograms are equal to 3.7 times 10 to the 7th milligrams? So that's a lot of milligrams, right? But milligrams are very small, kilograms are very large. So this should make our number quite a bit smaller as we go from milligrams to kilograms. So we're going to treat this like any other problem that we've done to this point. 3.7 times 10 to the 7th milligrams as a fraction, so put it over 1. We're still trying to multiply by a fraction. And then we're trying to get rid of, in this case, milligrams, right? So it's got to go on the bottom. And then, of course, kilograms on top. Now, here's where the chart comes in. Everything to the left is larger. So like giga is a really, really big unit. Kilo is much, much larger than milli, right? So anything that is larger in terms of the number relationship, you can put a 1 next to that unit. So 1 kilogram is equal to how many milligrams? Well, it's going to be a big number of milligrams because milligrams are really small. Now, the way I'm going to do this is I'm going to start writing in scientific notation. It's going to be 1 times 10 to some power. And the way we figure out what that power is, that's where our little chart comes in. Because what we can do is move, in this case, from milligrams to kilograms, and we can count 1, 2, 3, 4, 5, 6 spaces it took to go from milligrams to kilograms. That doesn't mean there are 6 milligrams in a kilogram. It means there are 10 to the 6th power milligrams in a kilogram, right? So there's a lot of milligrams in a kilogram. So, and as long as you put a 1 next to the larger unit, as long as you put a 1 next to the kilograms, you don't really have to worry about which direction you counted. So I went from milli to kilo, but you could go from kilo to milli, and you would still get 6 spaces, and so you would say 1 times 10 to the 6th power, okay? And that is going to allow me to cancel milligrams, and now I just get out my calculator, or you could do this one in your head because we're just dividing by 10 to the 6th, and so it should give us 3.7 times 10 to the 1st, or 37 kilograms. All right, and so that's our little introduction to metric conversions. We'll do some more next time in class. So make sure that you are ready with questions.